Up to now, I've shown you how we solve, using proper mathematical techniques, simple equations like this. But you'll encounter linear equations that don't look like this. So I'm now going to look at what you have to do so you can turn a range of equations into the form we see here so that you can go on and solve them. You may see equations like these. It's important that you're able to classify what the problem as such is with each of them and know how to deal with that problem. I'll just quickly say that in algebra, often there's more than one way to solve a problem. So what I'm showing you here is a general way you'll be able to tackle most of these types of equations. But what you need to do is learn to see what the problem is in each case. So in this first equation, the problem is we've got more than one like term on each side. In the second type of equation, we've got brackets. In this third type of equation, we've got an x on both sides. And finally, in this equation, we've got a fraction. So how do we deal with each of these? The first is easy. If you ever see an equation with more than one like term on one side or both sides, this is the first thing that you should deal with. Just simplify. We simplify just by collecting like terms. And now you can solve this equation because it's in the same form as this equation that in previous videos we've looked at how you would solve. The next problem to look at is the presence of brackets. And an easy way of dealing with this is just to expand the brackets. Now the more advanced students may spot another way, but until you get comfortable with equations, my aim is just to give you a simple set of rules that will work. So we just expand the brackets and now we have an equation that you can solve. Again, it's in this form that you're used to seeing. In the third type of equation, we have an x on both sides. And this is how we'll deal with it. Decide which x you wish to keep, this one or this one. But it always makes sense to keep the largest. So we'll keep this and get rid of the 2x. How do we get rid of the 2x? We do this by applying its inverse or opposite to both sides of the equation. And the inverse of plus 2x is minus 2x. And we just do that to both sides. Then we simplify. And once again, we have an equation that we can solve. So we're left with the fourth type, and I would describe this as the biggest nuisance. If you see an equation with a fraction, I'd always deal with this first, apart from perhaps collecting like terms. Yet the way we deal with a fraction is actually quite simple. Simply multiply the whole of the left and the whole of the right by whatever is on the denominator, or the bottom of the fraction. So I'm going to multiply every term by the denominator of the fraction. These threes will cancel. And we're left with a simple equation. Once again, we can solve. So there we have it, how to deal with each of these 4 types of equations, so we end up with the equation in this form that we can solve. I'll finish by showing you how I would tackle an equation that's a combination of these 4 types, this equation here. Now I could look at this in one of 2 ways. Either the third case, because it has an x on both sides, or the fourth case, because there's a fraction. Now either is fine, but my advice is generally whenever you see a fraction, deal with that first. As you gain experience, you'll see the best way in each particular situation, but I'm just giving you the smallest set of rules that I can. So deal with the fraction first. And we've looked at how we deal with this. We look at what is on the bottom of the fraction and multiply every term by this value. And a half x times 2 will be x. And so we end up with this equation. Now it's not finished because now we're in a situation where we've got an x on both sides. But again, we've looked at how we deal with this. We decide which of the x terms we want to keep, and usually we'll keep the largest, so we'll keep this. So we need to eliminate this x. How do we eliminate plus x? Well, the inverse of plus x is minus x, so we apply this to both sides. And finally, we've got an equation in the form that we recognize. And what I'm going to do is, without using the function machine, I can just see that I'm going to subtract 4 from both sides. Don't jump steps. Carry out the operation on both sides without doing too much thinking, and then only in the next step carry out the simplification. If I want to be certain this is correct, it's always good practice to substitute back into your original question. And so we can see I'm quite sure that my answer x equals minus 6 is correct.